Okay, let's explore this technique of integration by parts. And this technique is all stemming from the product rule for derivatives. So let's remember what that was. So if we have two functions, f of x and g of x, recall that the derivative with respect to x of f of x, g of x, equals f of x times the derivative of g plus f prime of x times g of x. All right, that's our product rule that we have seen repeatedly. Okay, so if we start with this expression or this equation of the product rule, let's go backwards. So let's integrate both sides with respect to x. So we are now going to integrate the derivative of the product with respect to x, and that's going to be equal to the integral with respect to x of this side. But since I have a sum, and I know I can split the integral of a sum into the sum of its integrals, I'm going to rewrite that as the integral of f of x g prime of x dx plus the integral of f prime of x g of x. I will not run out of room. dx. Okay? Now notice if I take the integral of this derivative by the fundamental theorem of calculus, this just drops out and I get f of x times g of x. So I undo what's being done here. And again, that equals the integral of f g prime of x dx plus the integral of f prime g dx. Okay, now to make this a little cleaner or easier to see, or in a form that will be easier to remember, let's do a change of variable. Let's let u be equal to f of x and v be equal to g of x. Well, this means du is going to be f prime of x dx, and dv is equal to g prime of x dx, just like when we did u substitutions. Okay, so now if we go back into this expression, our equation, and replace it with our new variables, so our f of x times g of x becomes u times v equals the integral of f, which is u, g prime of x dx is dv, plus the integral of f prime of x dxg is really v, there's my g of x, and then f prime d of x is du. Alright, now let's solve for one of those integrals, and it really doesn't matter which, but by standard, and what you'll see likely in your book, is if I solve for this one, so I'm going to move this one over here and I'm going to write it reversed, I get the integral of u dv equals u times v minus the integral of v du. Now this is the expression, or again the equation, that you will use to evaluate an integral by parts. Now the trick will be recognizing the integral you have and identifying which piece you want to be your u and which piece you want to be your dv. And so we're going to look at an example. Okay, this is an example that we are going to look at applying integration by parts. So remember, we want this integral to be of the form u dv, so that we can simplify it to this expression, u times v minus the integral of v du. Okay, so our task now is to figure out what in our original integral we're going to call u and what we're going to call dv. Now, we have two obvious choices. One is to say u is equal to t, and the other is to say dv is equal to e to the t dt. That's one choice. Or I might say u is equal to e to the t, and dv is equal to t dt. Now, hopefully the choices that we pick will make our new integral over here easier. So we'd like to go in a positive direction. So if I were to take the derivative of t, I'm going to get 1 dt. And if I'm to integrate e to the t dt, I'm going to get e to the t. Now, when I integrate the e to the t and get e to the t, I don't make it any worse. But when I differentiate t and get 1 dt, I make this one better. So that's kind of one way that we think about of guiding ourselves. If I go this way, if u is equal to e to the t, then du is e to the t dt. And v here, well, if I go backwards this time, I get t squared over 2. And that actually is worse, to go from t to t squared over 2. So, I'm going to choose this one to start with. I'm going to let u be equal to t and dv equal to e to the t dt, which means v is e to the t and du is 1 dt, or just dt. So let's just make sure I did that appropriately. There's my u, t, dv, e to the t dt. Good, there's my u times v. I'm sorry, the integral of u dv, which is equal to, based on the formula that we derived on that previous page, u, which is t, v, e to the t, minus the integral of v, e to the t, du, dt. So I've taken this integral and I've rewritten it in this expression where it still has an integral, but now this one is one that I can easily solve. So this is, make sure it stays on the screen, t e to the t minus e to the t. And in the end, let's put our big plus c. So that is an example of solving an integral by parts.